Thank you so much for joining in early in the morning, of course, on this Friday. Uh, and I have with me a very distinguished panel. And I wouldn't say panel, but a colleague of mine, Hari. He's got a lot of patents to himself. I was just learning while talking to him over the tea breakfast. He's got so many of them that it really makes it could actually make anyone feel, oh, really, have I done something? But the thing is, he's worked in various industries, and he just told me he's been to Himalayas as well. So welcome Hariharan. He's from Raymond's, and he's the CIO there. I have on the other side Mr. Raj from Shoubii. You've seen him on the stalls there, and I'm sure he'll be able to help you more than just enlightening us here in this room. So we have here today some time to delve upon this edge technologies. Well, it all began about a decade back when first time Bosch introduced this term in the Hanover Trade Fair in 2011. Yes, ladies and gentlemen, I'm talking about Industry 4.0. And yes, it was that particular thing which started from day one on 4 notes: interoperability, then looking at decision making faster, higher efficiency, and productivity. Now, it was this productivity and efficiency which has been driving since then the industrial domain. A revolution really has come up from the time it has been introduced, and today we see that nearly all systems have started talking to each other. If not all, I would say really it has really started talking, and the future is what we can see. It's going to be much more collaborative in nature. I would want to speak on this along with Mr. Hariharan. The very first thing when it comes to edge, how edge it is. Does it really have an edge, or it's a passing fad?
Interesting. Essentially, we talk about big data. Edge is exactly the paradigm and the opposite of it. Compute at the local level, gather intelligence at the local level, dump the data at the local level, preserve the data at the local level, don't send it to the central, decentralize. That's how our entire bioorganic system works. So we need to decentralize things rather than centralize it. As the CIOs or head ITs of the organization, we think about control, control, control. The whole thing is to decontrol everything. Let it flow symbiotically. The whole of the energy systems, whole of your systems, be it be your OT, any of your central making or any of your intelligence systems, let it be at the local computational level. I will not talk about AI, even though I hold patents on it, but let me talk about machine learning and deep learning. The whole of the future is essentially about localized chipsets, specialized chipset processing. So if you have something that works on sentiment analysis, it will be localized. Just like your mobile thing is still an edge device. It's going to compute across, understand what you like, what you don't like, generate the whole information package about it, and only communicate that. That is what is information. Data is garbage. Don't ever focus on the data. The data is where the whole garbage comes in. The security comes along with it. The entire decentralization is what we are looking at. Capture the information at the local level, compute it, send only the pure data, pure computational information at the central level. Rest of them can be dropped at any, except for forensic and compliance and audit levels, they can be dropped. So that's what I would focus on. And as I said, the future is all about specialized chipsets. They could be machine learning chipsets, they could be deep learning chipsets, and these are what are going to run across in the future. It could be for the drone industry, it could be for medical industry, it could be for your textile, it could be for your pharmaceutical. Those are the areas which we are looking at, and that's where the future rules. Thank you.
Very interesting. I think I started reading about this very, very recently, and I think we hadn't gone beyond thinking about the DCs, the hybrid clouds, the multi-hybrid clouds, and things like that. But I think what is more interesting to see is that also talking about edge, as Hari said, the thing is when you start sending too much of data onto the cloud, the bandwidth gets choked. Now, again, it's not just the bandwidth. The quality of data that goes in, probably there is one piece of information and 100 pieces of junk which goes in. How serious that decision making would be on the basis of this data, some petabytes of it, which has gone to the central, and when it's going to communicate back. I think there's a lot really to learn on edge. So whereas we were only thinking about, look, we get to get into co-location stage, we get into micro DC stage. I think we also have to start looking at the edge itself. Raj, I would want to ask you, you were from the consulting. How do you think has this been in the industry? How is this being perceived?
All right. So first of all, when we talk about edge, I just want to make sure we are all on the same page, right? It was already explained, but I just want to reinforce. So it's a technology where you collect the data locally, you process it, you store it locally, you analyze it, right? So a few years back, this cloud was the next big thing. So we started taking everything to the cloud, right? And it has its own benefits. There's a lot of benefits to say. But then from operational efficiency point of view, right? So edge is, when you take data to the cloud and then process it, there's always some latency, right? There's some lag. So to avoid that lag, there might be some decisions where you have to take, straight away, right? It's like, okay, my boiler pressure is going up, right? You cannot call your manager and then ask what to do. You have to do it straight away. Those are the kind of things that we want to keep it in edge, right? Quick decision making, where we do not want any delay in decision making, right? But there are many other things where you can always call your supervisor or manager and then take a call. Tank level is going up, can I reduce the plant load, for example, right? So those are the information, those are the kind of information you put it in the cloud. It's definitely useful, but wherever you want quick decision making, we'll have to try to keep it on the edge or locally.
Correct. I think a lot of things are going to start where the decision making, as Raj said, is going to be of critical importance. Hari, any use cases that you can cite off besides the drone and the couple of things that you mentioned?
Remediation.
Understood.
You should always use edge for remediation. Rather than information hoarding, use it for remediation, instantaneous remediation. Suppose if you're running a cloth mill across, you're running a process across, or if you're running a pharmaceutical or a batching process across, if you're running any kind of an optical algorithms across, the whole logic is to use instantaneous remediation. Yes, it requires some amount of machine learning thing that is to be passed across, and if you can custom build it, the whole thing can be used for instantaneous remediation. No information to share across, the system computes it locally, remediates it, instead of raising it to the supervisor, escalating it across, losing precious time and latency along the cloud. Use it for remediation. And both of the example which I gave earlier, drone industry, you don't have anything across to escalate. If you're doing something like a kind of an inventory across, and if you're running an oil rig, the whole logic is that the drone is not going to go across communicated. You use swarm computing for that. What you do is that the thing talks to the other ones. It could be using any kind of low latency technology like LoRa or anything, but then the remediation happens. That's what we discussed today morning also. Yes. Remediation should be fast, and that's where you should use edge or fog computing. That makes a clear-cut case for it.
Then how do you really justify tons of investment which is going in on the big data and things like that?
See, big data is not for tactical information. It is for strategic blow baiting. Anything you got to make a strategic thing across, you got to like on a long run, you got to do customer dynamics, that's where you use it. Otherwise, think about it. You run on the Facebook, you run on Twitter, you see a lot of emotions passing across. Those are not, essentially when you run it across, we call it sentiment analysis. The sentiment analysis block, you cannot gather it into the big data and use it after 6 months. It's garbage over garbage. The whole point is compute it locally, understand that whether the sentiment is going to get conformed into anything else. Is there a confirmation bias over it? If it is there, then you can do what we call as perception engineering. Otherwise, it's all garbage. Taking it to the central data, having 256 lines of data across, somebody is going to analyze over it, somebody is going to run algorithms over it, all pure garbage. By the time you have it and you cannot harvest it, It's like what we call is, seed gathering. In the agricultural industry, you got the seed industries, you got the seeds running across. The seeds do go stale. You lose the potency. That's exactly what the point is.
Understood. So it's more to do with the tactical part than the strategic part. Good. Raj, I would want to just bring out, I would want to ask you on these few things which I earlier said as well. These DCs are coming. We've got tier 4 DCs, tier 5 DCs. Then we have IoTs coming up, 5G is coming up, Wi-Fi 6 is introduced, SD-WAN is already in. All of this put together, where do you think edge is really going to fit in this whole infra game?
Right. Yeah, that's a very interesting question. We have technology upgrades every single day these days, and let me tell you one thing: edge is here to stay, right? We talked about a few benefits of edge over the cloud and even other technologies. So the ultimate success of any solution is, when the operator, I'm talking about manufacturing. So when the operator tries to record production or any information, right, or if he or she is relying for some information from the machines, if it takes even like 2-3 seconds, it's not going to be very successful, right? They are busy with many other things, and reporting is just one small piece of it. So the data has to be in the system instantaneously, right? As soon as the production is completed. Let's say we are producing a roll, right? Roll goods. As soon as the roll is cut, we need to know the roll length, right? Instantaneously, not after 5 seconds, right? And that can be achieved by all these, edge technologies. The other technologies are there to complement and support and help, but it's ultimately the edge tools and technology that gets the information very quickly to the production operator.
I can really relate to that. I think one of the use cases that we were also looking at is we are into basically gas pipelines. Now the thing is, when you have these gas pipelines running into many kilometers and miles, and you want to do really a surveillance part of it. Now there's a lot of data, so what do you use? We actually cannot use the physical supervisors. So you have to have some automated mechanism. If there is an automated mechanism, there has to be some compute which is happening at each stage. Now it just cannot be that between 66 kilometer and 67 there is a fault, and you really have to send this data back through whichever mechanism. And then there's somebody who's taking up some kind of a decision that yes, there is a fault there. So I think this is really going to be a bigger use case. I think a lot of other use cases as well, where instantaneous decision is required. So for instance, there's an autonomous car. So if there is somebody in front, there has to be decision there and then and there itself. So these devices have got to really take up. So as you said, remediation, obviously it's going to be one of the best use cases. Do you foresee anything in manufacturing other than remediation which really can be thought of?
Absolutely. See, the whole thing is collaborative working. Edge itself, would be it's not a single point stop. Unless you collaborate at short intervals, unless you collaborate with another what we call as another edge device, it could be using LoRa, it could be using any kind of protocols, BLE, beacons, anything. The point is to use swarm computing. Unless you have localized computing that collaborates with other into a larger piece, without having a centralized system and each one of them localizing the information, each one of them localizing the sensor inputs and making a decision making out of it and collaborating the same to the neighbor. So that each one of them will have a micro environment in itself. That's where the computational dynamics really works. So super specialized chipsets, as we are discussing today morning, the point is that you would have 6 different what we call as super crystallized chipsets, but each one of them would have different function. But the moment they understand that there is a problem or there is an attack or there is a remediation, they all collaborate at a single level. So use computational dynamics all of the power of one, and that's how we attack it. So swarm computing is the next stage. So many jargons, but essentially it's best use of technology, that's all.
Understood, very good. Raj, do you think, can you from your consulting experience, let us know where you have been implementing this, what kind of challenges have been coming up?
Sure. I can take one particular implementation where we had like say 20 different external systems. So we have the ERP for the planning and costing and other things. And then we have the execution system. SAP, we implemented SAP manufacturing execution. So we have the ERP manufacturing execution, but then we are relying on data from say 20 different external systems. It could be just a database or it could be from a PLC or whatever, right? So we had to come up with a strategy where we have the information in real time in the execution system, and we should have the data to analyze in real time, some data, not everything, right? And so yes, so that is where obviously we call it edge, but we had a I would say historian which is capable of storing tons and tons of information, right? So we were able to connect all these 20 different external systems into the historian. So it gathers all the information every second, millisecond, it stores, and then we use or we integrate with those historian to pull the required information into the execution system, right? So I can give an example where you take some information, develop some SPC charts, right? So you have a trend chart, right? So I mean that capability is available in other systems as well, but we can take the real critical data and put it on the floor, and probably put it on the monitor as well, right? So this is what I would call as edge, right? It could be any different machines or software that we use, but the ability to collect information from multiple systems, from the ERP system, right, and sometimes even from the execution system, and then manipulate it. How do we manipulate the data? For example, I was talking about SPC charts, right? So you could define your own upper limit and lower limit for some parameters, and it could generate alarms, or it could sometimes trigger an email message to some supervisors to make sure the operators are taking care of it. It could send some text message to some people as well. So all these are part of the edge, right? Yes, I mean we can do this with cloud technology as well, but there are informations or there are parameters that has to be monitored quickly. We have to take action quickly, and that is where edge comes into picture. And I mean in the same implementation I could correlate another thing. So there was we always take materials from one place to another, right? We call it as material staging, or when we produce the material we put it into inventory, right? It's a very normal process. But this particular client, they had AGVs, or automated guided vehicle, right? So those vehicles without any driver, just imagine a forklift without a driver, the forklift has to come pick up the material when it is produced and then put it in the right place, right? Same way you should able to bring the material at the right time for the production floor, right? And it's all automated. So and this automation we did through the edge technologies, right? There was a system called 𝐂𝐥𝐸𝐺. We were able to integrate with our integration tool called MII, and and there was so many complications which I don't want to bring it up here, but the timing is very important, right? You don't want the machine or the AGV to bring the material and wait here forever, right? At the same time, you don't want it to come late when the machine is ready to produce. So the timing is important, and also there are not just one or two AGVs, there are multiple AGVs moving around the floor. So everything has to be coordinated. So the edge or the technology, what we call as edge technology, really helped us in now making this a success.
Okay, I think one of the things that brings to the mind is, I'll come back to you, Raj. Hari, is on the infra part. When you look at so much of processing required at the edge itself, do you think there will be a huge compute requirement as such as well there? Because I mean, you're just not looking at mere logs. Here you're trying to see, with respect to an algorithm, if there is a remediation required, it has to be instantaneous. So are we saying that there will be a requirement of a huge infra, or some kind of infra there obviously would be there at the edge?
Exactly the opposite.
Okay.
Whole point is that you can use something as simple as an Arduino cluster or a commercial Raspberry Pi cluster. The whole thing is that the computational power goes down. You can run on low power devices. I'm talking about both physical power, operational power, computational power, dynamic power, storage power, RAM power. So each one of them can be frugalized. And that's where edge comes into the picture. And that's where it makes a business case. The whole logic is that you can run it on a very low, very thin power footprint and computational footprint.
Awesome.
Even the bandwidth is low. That's why I'm talking about linking up edge computing with something like BLE5 device or a LoRa device. So that's just, a small fragment of computation and what we call as data processing and data streaming. So instead of, having the bulkier data where, you need a huge infrastructure, dedicated infrastructure, here I'm talking about usable, scalable, extensible, differentiable kind of infrastructure. So you've got a Pi box that's running something else, you're using it as a print server. Hey, I can use it for computational dynamics. Let me just run it across. The whole thing is smart routing. The whole thing is smart routing. As long as you have specialized chipsets, being able to specialize for that particular task if there is a problem on hand, otherwise working as a generalized information processing system, that's where the magic is. It's going to be smart, low power computational device, just like your watches. They are all edge devices.
Edge devices.
Absolutely, you are using. The only thing is that we are not able to have a kind of decision-making system.
Understood.
Because the problem is that we are more running behind data. The whole logic is that many of you are using sporting application. The point is that, do you know what is the relationship between your HRV, your step rate, and the motor that you're running on, the stepper motor you're running on? If you can link all those three, this is a decision-making device. Otherwise, it's an information garbage generating device, which you can see on this snapshot. You can see, okay, 16,000 steps run. What's the amount of data that you had? And what are you computing out of it? Otherwise, it will not be a decision-making system. It will be an information junk garbage gathering system. And it will make you more anxious. That's exactly what we do as a CIOs and head ITs of the companies. That's what we do. We create a panic scenario out of ourselves by hoarding data. Huge amount of data are being hoarded. Huge amount of data are being computed with lot of latency and what we call as data poisoning. I used to be on the other side of hacking, so I can tell you, data can be poisoned. And once your data is poisoned, you run with the wrong set of information. And that's where the real hacking is. Tomorrow, the hackers are not going to steal your data. They are going to poison your data. That's exactly what it happens. And that's the strategy. So think along on those lines. Thank you.
Very good. I think not to really, just to take what Hari said, I think further is, if we look at this data of either any kind of a watch, Apple Watch, or anything which monitors your steps, or how it just does some calibration on how many steps and how many kilometers. Why shouldn't it actually also look at your heart rate and give you some kind of a decision making there? There is obviously some kind of a decision required from a prescribed authoritative entity, otherwise they'll get into a soup. But I think some kind of these things can really give some kind of an edge. I think they are coming up, a lot of companies are coming up with the devices which will be implanted on elderly people to monitor how their heartbeats are, how their BP is, how their diabetes is at a certain point in time. And if there is a corrective action required at that instant, I think that is where this technology is going to come up in future, I think.
Remediation. Again, the word is key, is remediation. Instead of you getting into the data, analyzing it, oh, mera BP itna badh gaya, mera HRV itna, it's all garbage. The point is you need to correlate with the data model. What is the data model that you have? Nothing. You're going to consume. Today morning somebody said, I think gentleman from Dell, that hey, the point is that I would require a technology that allows me to consume anything across but still metabolize it. You are not going to metabolize it. The fat cell will convert into adenosine triphosphate and you are going to develop a lot of fat. That's it. You're going to consume that fat, consume it into your cross and put in testosterone and then build up muscle. How is that whole dynamics working? Sorry, I got into biology, but the whole logic is exactly that. We need to understand what is the information that comes out of it, automate it, and then you will have the whole churn running. Otherwise, it will be, you'll have nice, fancy graphs running across.
It's very, very good, very cool. That's true. That actually is true. I think Hari has been on the other side of the CIO community. So he's been involved in hacking as well. So he was a good hacker. So I actually read through while I was going through these hackers thing a few days back. They are now getting into data poisoning, as he said, rightly said. They don't want your data. They just want to corrupt it. Whether you take your data, keep it with you. I don't need any bit of it. But I'll make it so useless that so much of data, I think there is some kind of a constraint even taking so much of data or just doing an encryption. They will just spoil your data.
No, sir,
How
it's
much?
not poisoning. It's not poisoning, sir. See, the whole thing about poisoning is something else. The point is misleading you. The point is giving you the wrong set of computational data to run it across. So you will be running your computational power on the wrong end.
Set of data.
And by that time, I will use the loopholes to build in my own fort. Make it simple as magic. I misdirect you, and by the time I'm running my tricks. So that's where the whole logic is. So most of your firewalls will be running across on those kind of an attacks, whereas you should be setting up fire traps or what we call is, honey traps to gather the information. That's what we all do. That's life. That's business.
Very true. I think what I was saying, what I was thinking around was, yes, a lot of hackers now are actually getting into not taking data, not encrypting it, it's just spoiling your data. So you get so much of additional information and you're not able to make a decision whether this is right or that is wrong. Raj, from your side, how do you think is this really working from your from data, from the infra perspective? What has your experience been?
Yeah, definitely, from the data perspective, like I said, there are every machines or every sensors that you have on the floor has now the capability to gather and send information, every single second or millisecond or whatever, which means we have millions and millions of data record to handle, right? So there are different ways to handle it. You can put it on the cloud. I mean, the cost is going to be very high, right? And there's cost of transferring the data to the cloud as well, right? But then when you talk about edge, you have your servers locally, right? You can store all this information here and then take only the relevant information to the cloud. So obviously, when you want to handle data, right, edge is the way to go, right? Because today, like I mentioned, all equipments are capable of gathering and then sending so much information, and we need a place to store it, right? So we can retrieve it and then make value out of it. So yes, edge technologies is the way to go when it comes to storing all these data.
While staying on this, what is on the security? What's the take on the security?
Yeah, so there are both pros and cons, but consider this: you have the data in your network, right? So that is edge. So in your factory, you already built all your firewalls and other things, right? So obviously the data is going to be a little bit more secure when it is here, right? But then if you take it to the cloud, still it is secure. I'm not saying that the data in the cloud is not secure at all. I mean, any cloud platform will have its own security features. Say, let's say Azure or Amazon or whatever, any other cloud platform will have its own security features, and then compare it with what you have for your particular factory, right? So obviously, your data is more sensitive for you. You don't want it to be shared with others. I mean, some information can be shared. Most of it you would want to retain it within your own organization. So yes, so there are both pros and cons on both sides. It has to we'll have to evaluate case by case. But if you ask me to summarize, yes, from security point of view, storing the data locally is more secure than taking it to the cloud and storing it. But then, like I said, it has to be taken case by case, and then we'll have to find the right approach.
Okay, how about you, Hari? What do you think?
It's a double-edged sword. It's very easy. The point is that you've got a SCADA controller, a PLC controller. Okay? It takes 3 minutes to hack the system because the system itself does not have security features built in, right? So the point is for a hacker is that to make that information potentially useless and stale. That is what your strategy for edge should be, because it's very easy to hack the best of the industrial systems because they were never built for security. Please understand that. They were never ever built for security. Neither is your smartwatch built for security. The point is that I don't need to access your smartwatch. I can use Tempest, electromagnetic waves, to just transfer the information over there, and it is very small bits of information. So the whole logic is to make that information stale. That's exactly what the point is. Use the opposite of latency. Make it stale so that information lies pretty useless, and that's what your edge strategy should be. Edge should not be implemented just for the frugal benefits. You need to have a clear-cut, concrete strategy about it. Otherwise, your edge whole strategy will fail. They will fail at the tactical level. You will stand totally exposed. That's the biggest problem with edge. That's the biggest problem with any of your smart devices. It's very easy to hack them because they were never made for enterprise level security. So the point is, make it lose the latency, buy time, make a strategy that way that that the data remains absolutely useless and raw. Otherwise, you're going to screw yourself on your head and beat yourself on the head by using unplanned edge. Most companies do that. We all as CIOs goes, unless you're an innovator and you go into the depth of it, most of us are onto different levels of hype. Somebody comes and say, oh, H4, fine, H4, H5, H6, anything happens across, we get into the loop. But we never look at it beyond the marketing piece. The whole thing is to understand what is the ecosystem all about like, and then barricade yourself, pilot it, test it, and then release it. Just don't fall into that marketing loop. Otherwise, edge is a fantastic problem. Unresolved, open-ended problem, and it will be.
Yeah, I think because one of the other reasons probably is that just giving extension is it's running on the core system itself. So the security obviously and the kind of data it is assimilating, it has to be lot secure than merely like any other data which is getting transferred to cloud, which obviously is quite secure. But here I think we're talking of raw data, the data of the individual machines and the raw data itself. So I think there's a lot really to learn from this. Quite scary, really.
It's a one-way traffic. See, it's a one-way traffic. You need to understand what you need to secure and what you need to release. You don't need to secure the information sent from one edge device to your master controller. That's raw data. Don't invest your money on that. And most of the marketing companies and the technology companies will say, hey, it's a two-way traffic, you need to invest here and there. No, don't invest there. You will lose on the latency part. Rather, whatever information and decision making you're passing back to the machine, invest on that. Otherwise,
rather than it's securing your data which is going to control, secure what is actually getting passed on as intelligence.
And edge, we also have what we call is single level hops and multi-level hops. Again, it's a long drawn traffic, and the topic is also very complicated. But the whole point is that process the information at the shortest possible physical or virtual hop. The moment you take it to a longer gap, you have the problem. So that's where you use low power technologies like LoRa or BLE or anything rather than wired. The whole thing is to obfuscate the whole traffic in a very short way and a very short hop and very less. So 2 KB, to encrypt 2 KB, I can put in a lot of resources.
But does it really make a sense?
True. We as IT guys, we waste and put in the corporate effort and money on the wrong end. Sometimes we do. We all get fascinated by technology. Happens.
Oh, quite insightful, quite insightful. I think few other things are coming up into this is something like a CDN, something like content delivery networks.
Right.
Does it really make sense to compare it with them, or it's a futile exercise?
I would say yes, because content development, I would say cache data development, right? Cache data. So it's basically caching the information. So when we try to access the information, it shows up pretty quickly. So it's a form of an edge technology. So I think you have all your cache servers locally, right, not on the cloud, and it just helps to improve the performance of the application, right? I mean, you can take any application you use, in your execution system, you have your material number, for example, right? So first time when you are accessing the material number or even the transaction to access the material, it takes a lot of time to load. But next time when you access the same transaction, it loads very quickly, right? So that's because the data is already cached in the local server or cached server. So yes, I think it makes a lot of sense to have a cache server as part of the edge technology.
How about something on fog computing that was also coming up, which Siemens brought up, something similar to this?
I'll answer the earlier part. Whenever you're catching it, the whole potential for introducing and poisoning data is a lot more.
Okay.
So the moment you think about it, see, one, we can invest on technology for technology's sake, but then cache brings in its own set of complications. So it's very easy to poison up the data over there and corrupt the data over there or misdirect data over there. So that's the problem. So that's one of the points. The second point which you asked about is fog computing. Different terms, different technology, different, but essentially the whole concept of it is that you need to re-engineer different bits of fog technology to make it suitable to the IoT as well as to the edge computing. Otherwise, it remains an acronym for acronym's sake. So that's where the point is. That's what I said. The hops is what essentially dictates your technology for you.
Yeah, I would just like to add a little bit to that, the fog technology. So we were talking about we have millions and millions of data locally, right? And on the cloud, we need some information, not everything, right? So because it's going to be very expensive to store all the data in the cloud, right? Say, for example, you talk about Azure or Amazon. I mean, you have nice packages and you'll be excited when you subscribe. But at the end of the first month, when you actually get the invoice, that is when you realize how expensive it is, and then you quickly try to re-strategize. So that is where the fog thing comes into picture. So it does not send the millions of data to the cloud. It filters. It's like a filter, right? It filters out what is the information that needs to be sent to the cloud, right? So let's take vibration monitor, right? So you have vibration parameters recorded every single minute, right? But what you want to send to the cloud is when there's a spike, right? So you send only the relevant information to the cloud, and we can achieve that using this fog technology. Basically, it's a filter to reduce your cost of sending the data to the cloud and storing in the cloud.
Again, very interesting point. When you talk about fog computing, mist computing, we'll hear all the rainy season words about it, but that's how it is. So the whole logic is that, the whole of the fog, these are especially used in casinos and certain online environments where I earlier worked up with. Essentially, what you do is that you introduce a zero trust element over there. So that's where you benefit from the real perception of fog computing. The whole logic is if you can build up a blockchain, or if you got the Ethereum of the systems of the world, or you industrialized your blockchains, that's where you get the real benefits. You're sharing an unnamed, anonymous information trusting blocks over there and use it for computing. So that can be used as a very smart handler, if at all you can build one.
So that's used in casinos?
That's used in casinos, sorry.
Very nice. I think another thing that I would just want to probably bring is these then it's the kind of senses as micro DCs.
Right.
So rather than a full-fledged DC, it's just a micro DC at the edge, at the place where you need it, basically. Now, with that in place and with so much of information that you've shared, do you think DCs will become, I wouldn't want to ask as a direct question, but what the threat is to a DC?
See, that's what I said,
Because I think the main reason why I brought this up is when you have so much of processing going on at the edge itself, and only once in a while it goes back to the main server for strategic purposes, I think this will some point in time begin to get capitalized more than merely looking at DC which has got which will be used for different purposes.
Think of it like the analogy of a blockchain again. I use mining as the localized potential to authenticate. The nuggets of gold are shared in the blockchain registry. So think along those DCs as the where you're sharing your golden information. And the rest of the processing material can be done at the local. So DCs are not going to go obsolete any day. The point is that you're going to have your bulk load of data over there where you can run your semantics or analytics over it. And this is where your localized tactical information is. So that has a different set of functions. So they will be in business. This has a different industry where you can optimize on cost and latency if you can. And if you re-engineer it properly.
Very nice. Thank you everyone for hearing to this. And by the way, Hari has got 40 patents to himself, and from the time he was doing his engineering. Thank you, ladies and gentlemen. Thank you for being a very patient listener. Thanks a lot. Thank you so much, Hari.
Thanks a lot.
Thank you.
Thanks, Raj.
Thanks a lot, Raj. Take care.